Hello there. In this video we're going to graph rational functions, and that requires doing an analysis first. Step one should always be to try to factor both your numerator and denominator. And once you have it in this form, you can begin to answer questions about where the zeros are going to occur. I think one of the first steps should be establishing the domain. So we can plug anything into this equation, get an output, unless we plug in a 1 or a 2. That's when the denominator is going to equal 0. Now, interestingly enough, this is not where the vertical asymptotes, well, its vertical asymptotes are related to this, but the vertical asymptotes aren't simply 1 and 2, because notice that these are going to match up. That means that there's a hole at 1. And to figure out the elevation of that hole, you have to plug the 1 into the f hat form. Didn't plan on doing that one. So you plug in a 1 into that, you get 2 times 1, it's 2 minus 3, so negative 1 over 1 minus 2, and that's negative 1, so negative 1 over 1, there's a hole at 1, 1. Interesting. Now the other domain air, that's going to be our vertical asymptote, and that's at x equals 2. Okay, so then we can start doing the other part of our analysis of where are these x-intercepts. It's when the numerator is equal to 0, so I'll do the f hat form. That's going to be at, move the 3 over, 3 halves, or 1.5, comma 0. 1 is not an x-intercept. Remember, that one was a hole. You can't have both a vertical asymptote at 1 and an x-intercept at 1. That's a contradiction. Those are mutually exclusive. It's neither an x-intercept or an asymptote. It is a hole. Okay, so that's the x-intercept. Let's get the y-intercept. So you plug a 0 in. Let's do the f hat version. Actually, you could even do the original one. All of those become zeros, and you get 3 over 2. Interesting, they're kind of mirror images of each other. Well, I guess it just worked out that way this time. Okay, so we can begin to plot some of this information. I'm going to do the scale on this so that it's going, each step is 0.5, so that's 1, that's 2. Otherwise it gets a little bit crowded. So I have an x-intercept at 1.5, 0, that's going to be there, and a y-intercept at 0, 1.5, that's up there. Also, I have a hole at 1, 1, so boop, and a vertical asymptote at 2. That's something that's getting closer and closer to, but won't touch, approximates in the limit. Okay, now the other thing that I think we're going to want to figure out is the eventual behavior of this. So what's going to happen in the limit, and what we have is a quadratic over a quadratic. So this is going to be case 2 for us. So here we go, case 2. I'm just looking at those largest terms. Those are going to cancel out, and I got it at 2. So horizontal asymptote at y equals 2. Okay, so I need to have it go through this point, well, not go through, but get near this hole, go through this point, treat this as an asymptote, treat this as an asymptote, and probably come in from the top side since I'm not squaring anything. So I believe the behavior is going to look like, there's our hole, and then it's going to come in from the top and go towards that one, also in the limit. Okay, thanks for watching. Character and Scholarship for Life.